Here's pre-calc. It's part 2 of your lecture for 7.1.3, 7-31 limits from a graph. The graph of y equals g of x is shown at right. Use the graph to complete each of the limit statements below. So they want the limit as x approaches -2 from the right of g of x. So x has to approach, x is going to approach -2 from the right. What's the limit? So that means what's the y value? So the y value is -1. Okay, when they ask for a limit, they want the y value as you're approaching x, either from the right or the left, or sometimes if it doesn't say it means from both sides. So now x is going to approach -2 from the left. So from the left, and it has to approach -2. So it's still going to end up at x equals -1. Okay, now they want x to approach -2, but they didn't write if it should be from the right or the left. So they want a two-sided limit. They want me to, where does it approaching from either direction as I get closer to the x value of -2, what's my y value? Well, it is -1. So it's -1. And you'll notice that the right-hand limit and the left-hand limit matched, and so then we can write it this way without specifying whether it's the right-hand or the left-hand limit. So this one, we're going to approach 0 from the right. So, well, here's 0. So if I approach it from the right, like that, I'll probably get it down to -1. And if I approach 0 from the left, this is 0, right? The x value of 0. The y-axis is when x is 0. So if I approach it from the left, I still end up at -1. So the limit as I approach 0 from, well, the right or the left, since it doesn't specify, I'm approaching 0. The y value is going to be -1. And notice they matched. The left hand and the right hand and the left hand limits matched. And so I can write the limit. Now, I'm going to try to approach x, or x is going to approach 2 from the right. So here's 2, and x is going to approach from the right. So it's actually going to end up way up here at 6. Now x is going to approach 2 from the left. Well, here's 2. The only way I can approach it from the left would be to come down here like this. And so as I approach 2 from the left, I'm going to end up at, I guess that's 3 right there. And so since these limits don't match, when I'm approaching 2 from the right, I got 6. When I approach 2 from the left, I got 3. The limits don't match. So if I am asked for the limit as x approaches 2, I have to say that it does not exist. And that's because the right hand and the left hand limits don't match. Okay, like they don't come to a, like if I approach from both sides, I end up in 2 different spots. So the limit doesn't exist. And we're just going to do this one more problem. This one says limits from a table. Look at the table of values shown below for some function h. So now we don't have a graph. We've just got a table. Write 2 one-sided limit statements that correspond to this particular function. So it looks like see how my x numbers, they're kind of getting like, you can kind of tell that they're getting closer and closer to 3, even though we don't have all of them. Like, if I start way over here, I'm a little less than 3, but this one's a little closer to 3, a little closer, and you have to assume it's getting closer and closer to 3. And then eventually it's going to go a little higher than 3. and a little higher. So I feel like they're wanting me to say that x is approaching 3, and if I come from this direction, I'm approaching 3 from the left, and if I come this direction, I'm approaching 3 from the right. Write two one-sided limit statements that correspond to this particular function. So they already wrote it for us. The limit as this function approaches 3 from the left is about 6.2, and they just did that because see how this number, the y number, well, h of x, which is the y number, it seems like it's getting very close to 6.2, and you have to assume, see how it's getting smaller and smaller? But it's not, it doesn't continue to keep getting smaller, or well, it does continue to keep getting smaller. But you'll see that when x is 3, it's somewhere in between 6.2, and isn't that very close to 6.2 because it's 6.19. So that's why we're kind of guessing that as x approaches 3, f of x has got to be getting closer to 6.2. Because if you just, 6.2 is like in between these two numbers here. Okay, so they're both, the limits are the same from the right and from the left, or from the left and from the right. So does the limit of h of x exist as x approaches 3? I want to say yes, because they're both trending toward the y value of 6.2. Like it really looks likely that about 6.2 would be in here, because this could maybe this would be 6.201. You know, I mean, we don't know exactly what it would be. And then 6.2 and then 6.199, or you know what I mean? It just looks like it's getting from either way, we're getting towards 6.2-ish. So it says, yes, the limit exists since the limits as x approaches 3 from both the left and right hand sides are equal. They're both 6.2. And then what is the value of h of 3? Well, we don't know for sure. We think it's about 6.2. We think h of 3, because we know h of 2.999 is 6.202, and we know h of 3.001 is 6.198. So we can guess that it's somewhere very close to 6.2, but we honestly don't know for sure because we don't have the equation of the function to plug it into. All right, that's all I got. I hope that makes sense.